Hi guys, and this is a new try for assessment and reasoning questions. So hope you know how to attend the assessment and reasoning questions. There will be two statements, and first of all, we need to check given the two statements are true or false. And if you find whether the given two statements are true or false, then we need to try to find out whether there is a relation or else the given reason is a correct explanation of assertion like that. We need to try to find some relation between them. So if we can't find any relation between them, we can directly go for the option B, which is not correct explanation. And if we find a relation, that's or else in other words we can say it as if we find that reason is a correct explanation, then we can go for the option A, right? So let us go for the question directly. So here the given question is, if a dielectric is placed in an external electric field, then the field inside the dielectric will be less than the applied electric field. So here the notable word was field inside the dielectric, right? So let us read the reason also. So electric field will induce dipole moment opposite to the direction. Okay, first of all, here dipole moment opposite to the field direction. This is the notable words. Okay, so this question is from the chapter 2 of NCERT. So electrostatics and capacitance, right? Electrostatic potential and capacitance, the chapter name, right? In that there is a topic called behavior of conductors in an electric field. So and then we have dielectrics and then polarization. Out of the two topics, this question was framed, right? So let us take those concepts. Let us have a small discussion or explanation, and then we try to find the answers given here. There are four options, right? Okay, first of all, if I place a conducting slab in between the capacitor plates, or else you consider that a positive charge distribution, negative charge distribution is there, and if there is a positive charge and negative charge distribution, surely there will be an electric field, right? Let me name it as electric field, external electric field, right? So then I'm placing a conducting slab. Let me name it as a conducting slab. Why I'm naming it as conducting slab? In the sense it's a conductor, right? So if I place a conductor in between an two charge distribution here, then inside the conductor what will happen? Inside the conductor, the positive and negative charges will try to split it up, and the negative charges will accumulate at the one end and the positive charges will try to accumulate at the one end. Then inside the conductor, if we see, means here there is a separation of positive and negative charges, and that means these charges can produce another electric field. So that electric field will be in an opposite direction with respect to the external electric field. External electric field will be from positive to negative, and here also the internal electric field is from positive to negative. When we look at the direction, positive to negative is in this way, and here the positive to negative is in this way. So therefore the two electric fields are opposite to each other. And in the conductor, what's the specialty about the conductor means, if you place a conductor in between the electric field, the conductor will try to produce an electric field which will be equal to the external electric field itself. So therefore the net electric field will be zero. This is in terms of conducting slab. Okay, what will happen if I place an insulator, or else I can call it as an dielectrics, right? So if I place a dielectrics in between the charge distribution or else capacitor plates, right? So like the conductor, positive and negative charges won't split up, because the dielectric we have a compact or else a very stable electronic configuration, and here the split up will happen in terms of a microscopic manner in the molecular level, or else very atomic level, the molecular level or atomic level, the positive and negative charges slightly displaced from their original positions. So therefore dipoles will try to accumulate in the dielectrics, right? So let me consider these small rounds are the dipoles which are present inside the dielectrics, right? Okay, so here let us consider the dipoles which have been developed here. Even though if I cancel out the positive and negative effect, so in this edge I have a positive charge, in this edge I have a negative charge, and that means there will be an electric field, and that electric field I name it as an internal electric field because it was produced by this dielectrics, right? And there is another thing, external electric field also there. That external electric field is traveling in this direction, internal electric field is traveling in this direction. And now here when we talk about the net electric field, it will not be equal to zero, because in dielectrics the electric field developed, which is very small in magnitude, which will not be able to cancel out the external electric field. Therefore the net electric field will not be zero in terms of dielectrics, right? So in terms of dielectrics, the net electric field will not be zero. But in terms of conductors, the net electric field can be equal to 0, right? The question is not about the net electric field is equal to 0 or equal to 0 or not equal to 0. That's not a question, right? So here when we look at the question, if dielectric is placed in an electric field, okay, dielectric is placed in an electric field, right, then the field inside the dielectric will be less than the applied electric field. Surely here the magnitude of the electric field produced by this dielectric is very less, and that's why the net electric field is not equal to 0, right? So therefore the assertion is correct. Then we look at the reason. Electric field will induce dipoles. Yes, electric field will induce dipoles. Dipole not, it's a dipole moment. Okay, dipole moment. When we think about dipole moment, so if there is a positive charge, okay, if there is a positive charge and if there is a negative charge, these two things must be separated by a 2a distance or else very small distance, and the dipole moment will be traveling from negative to positive charge. So the dipole moment vector will be in this direction, right? So the dipole moment will travel from negative to positive. So that's what the dipole moment. Here when we look at this direction of the dipole moment, so negative charge is here, positive charge is here, so the dipole moment will travel from this end to this end. So dipole moment direction is this. So when I look at this diagram, the dipole moment direction is towards the right hand side, and the external electric field also towards the right hand side, right? So electric field will induce dipole moment opposite to the field direction. So opposite to the field direction is not true. Here external electric field is towards this right hand direction, and dipole moment is also towards the right hand direction. Therefore both are equal in direction or in the same direction. So therefore the given statement is wrong. So let me choose. So first one, assertion is correct and reason is wrong. So I can go for this option, A is true or is false. And that's it, guys. Thank you. If you like the video, subscribe the channel Learnomanics.